to graph, we must know the formula. Y equals mx plus b. Oh, thank you, Mr. Neal. Oh, sorry. We must know the formula. Y equals mx plus b. So, in the formula, b is the y-intercept, right? And this is where, on the graph, y will be on the vertical line. And m right here is the slope. So this would be known as the rise over the run. This first equation that we're talking about is known as the slope-intercept equation. This is the slope-intercept equation, and then we'll start talking about a different formula that can be written in standard form, and whichever way is easier, you can use both to be able to graph. The next equation we will talk about is standard form. And this form is basically adapted from slope-intercept. And just in case you forgot, slope-intercept is y equals mx plus b. So a different way that it can be written is in standard form. And how you write this, how you write standard form is ax plus by equals c. So as you can see, it's basically the same concept, just written in a different way. So here, y would be the same as this, with an extra value if it's needed. And then here, mx is ax, so it's the same value. And finally you have c, which is the same as b.
This is standard form equation, ax plus by equals c, and this is your slope-intercept form, which is y equals mx. And here we have an example of a standard form equation, and we're trying to get it into slope-intercept.
For this example, we're trying to get it into y equals mx plus b. So this means that we have to get y alone on one side in this equation. So this means that for this equation, we have to try to get y alone. And the way we do this is we try to eliminate what's on this side and move it to the other side. So the one way we can do this is that we can subtract 3x from both sides, so that this way we can get y alone. As you can see, we still have 6 on this side, and we have to try to move it to this side. So that the way we can do this is by dividing 6 to both sides. So we get y equals negative 3 over 6 plus c. And since we have a fraction right here that can be, so then we have negative 3 over 6, and we can simplify this even further by dividing by 3. So negative 3 divided by 3 is equal to negative 1, and then 6 divided by 3 is 2. So this is what you can simplify it to, and your final equation would be y equals negative 1 over 2x plus c. Okay, so this is the final equation that we had. So in order to get it, to get the c, or the y-intercept here, we would have to plug in coordinates to be able to find the value. So for example, we can use the coordinates 0, 6. And basically, this would be x and y, and they would have to be plugged into these numbers. So when we plug them in, we get 6 equals negative 1 over 2 x plus 6 equals 0 plus c. So then we can move 0 to this side, but it's basically no value. But just in case, we can subtract to both sides and get 6 equals c. And this value is what c is.
So this is basically your final slope-intercept formula, which is y equals -1 over 2x plus 6. And we got 6 from plugging in the coordinate value. Now that we have this formula, we're finally going to teach you how to graph with slope-intercept formula. Now that we're going to learn how to graph, you always have to remember that your x-intercept is always going to be horizontal and your y-intercept is always going to be vertical. This equation that we got from solving from the standard form to the slope-intercept form, we're going to use to graph it. So this value, the one next to the x, is always going to be on your y-axis. So this is your y-intercept, so you go on the line for y to find 6, so 1, 2, 3, 4, 5, 6. You plot a point, and then this is your rise over run. So since this is negative, you go down 1 and run 2. So this would be your line.
Okay, so basically how we got the y-intercept is just using the vertical line, which is the y-intercept. And that's basically easy because we know that when we go up 6, since it's positive, our point will be right here. And then the way that we find our slope, mx, this will always be our slope, and x is just guiding us to where it would be on the graph. Okay, and the way that we find slope is using rise over run. So for this, we can basically see rise over run here. Since the rise was -1, that means that we would have to go down 1, and then we run, so this means that you're going this way or this way. So when you run, it's +2, so over 2. So it's telling you that it's going to go over 1, 2. As you can see, 6 was right on this line. Now we're just going to go over 1, 2. And that's how we got 2. Okay, so in terms of direction, for the rise, you will always go up or down. As you can see, whenever a value is negative, you will always run down. But when a value is positive, you will always go up using this. And then for the run, this is a little bit different because you can either run this way or this way. So this means that you can only run to the right or to the left. And in most cases, when you graph an equation like y equals mx plus b, the slope-intercept form, you will most likely run this way rather than this way. So most likely, when you graph, you will always be running to the right rather than running to the left.
Basics of graphing. We're going to teach you how to graph inequalities. Okay, before we get to graphing inequality, we want to make sure that you know what an inequality is. An inequality is an equation that uses less than or equal to, greater than or equal to, instead of the equal sign. An example of an inequality could be x is less than 3. So here x could be any number that is less than 3. So here it would be 2, 1, 0, -1, and so forth.
No.
Another example could be x is less than or equal to 3. So here x can be any number, but you can also, because it has equal, it can also be 3. So it can be 3, 2, 1, 0, and so forth.
This is because it is less than or equal to.
Okay, this process can be applied to both of these, but you always have to remember that the variable always has to go first. So here would be x is greater than 3, or x is greater than 3.
What happened?
And if you want to make sure if your answers are correct, you can
Plug
also
in values to double check.
So when you graph, when you're ready to plot the points, depending on which sign you have, so this is greater than, less than, greater than or equal to, or less than or equal to. If it's less than and greater than or equal to, it's always an open circle. And if it's greater than or equal to, or less than or equal to, it's a solid circle. How you can remember this is a solid dot for the solid line under, and when you remember this, you can always remember the other.